Now that we have a project prepared to run a local web server, we can explore the JavaScript fetch request. Before we begin, make sure you have a project prepared with the code we wrote in the last session. If you do not have this, you can download the source code included with this session. First, let's define a simple GET request in the run script. This will define a GET request that sends the text response, "Hello." To test it, start the web server. And try to access the URL in your browser. A page should load with the text, "Hello." Keep the web server running in the background. I'm going to digress a bit. Before we go any further, I probably should explain a bit about REST architecture for those who are not as familiar with it. REST stands for Representational State Transfer. Fundamentally, it's a definition of standards used between the server side, which in our case is an Express web server, and the client side, which is the web browser in our case. As the name suggests, the idea is that the client and the server are only communicating states, or resources, based off an established messaging format, and are independent of one another. The client can make requests to the server in the form of HTTP requests. These requests include GET, POST, PATCH, PUT, DELETE, and a few more. A GET request is a request for information about a resource on the server, and it must not modify the server's state. A POST request is a request to create a new or replace existing resource on the server. We'll be using these two request types in this session. A lot more can be said about REST, but these are the basics. Fetch is a function exclusive to the browser's implementation of JavaScript for sending requests to the URL specified in it. It takes a URL and optional parameters as input and returns a promise that resolves once the request completes or fails. It's similar to the XML HTTP request object in JavaScript, but instead of returning an object that has event listeners, or can have event listeners, it is predominantly driven by promises. Now that we know how the GET request we defined works and the browser is able to access it, let's try loading this content with an ES6 fetch request. Here's the basic syntax for loading the request we just defined in the Express server. After saving this file, Webpack Dev middleware automatically recompiles, quote unquote, the source files, so all we need to do now is refresh the page. In Chrome DevTools, if we go to the Network tab, we can see that a request was made to special message, and it succeeded. In the console, we see some sort of object was returned in response to the request. This object is known as the response interface. To parse the message as text, we have this promise resolution handler return a result of response.text, which returns a promise itself that resolves once the text content is parsed. Then, add another promise handler to the chain that displays what the text is. Let's try defining a POST request now. Stop the web server and open a run.js file. First, you'll need to let Express know that it needs to be able to accept JSON-type data from POST request. So right after the Express app is created, add this line. Next, we'll make it so that a variable defines what is returned in the GET request. Now we'll make it so that the POST request can change this variable. The app.post function is similar to the app.get request. You specify a URL and a function to invoke when the server receives the request. Both requests will send the message back, but this one will change the message to match whatever is passed in the message body. Actually, we probably should ensure that valid data is sent before updating the variable. Add this to the post request. So if a message is not included in the request, it sends 400 error and the message. Now, back to the JavaScript that is run in the browser. Let's write a function that we can invoke from the JavaScript console to send a post request. I'll explain each line as I type it. We'll stick everything in the update message function that we can call at any time from the browser console. That way we don't need to bother with creating HTML elements. Just as before, we'll create a window.fetch request. The first argument is the URL, which will be setMessage. The optional second argument is an object that contains a number of parameters. First, the method. The default method, if no object or method property is specified, is get, as we saw earlier. In this case, it's post, and we need to explicitly state such. Next are headers. Headers specify to the server what kind of data the client is sending to it. In the fetch request, this is an object itself that contains a number of optional parameters. We just programmed the server to accept JSON type requests, so we'll specify that in the content type property here. After the headers is the body option. This will be the actual data sent from the post request. Here, we'll send a JSON string via json.stringify of the message. And that's the post request. The promise fulfillment handlers will actually be the same as they were in the get request, so we can just copy-paste those now. Alright, start the web server, refresh the page, and open up the console. We can see that the console still shows the response object and hello from the get request we programmed earlier. Now, invoke the function we just defined in the console. The console should generate a similar response to get, except a new message is shown. Now, refresh the page. If everything went well, the new message should appear in the console this time. The state of the server was updated with the last request. Try changing the message again and refreshing. And that's the basics of the fetch request, as well as a brief intro on writing REST endpoints in Express. In summary, the fetch request allows the client side to make calls to the server side in a relatively straightforward manner, making heavy use of promises.